we're going to talk about the sine and cosine functions on the plane. Now, if you've taken trigonometry before, you might remember sine and cosine functions involving a bunch of right triangles. We're not going to do that presentation just yet, but we'll get there. In the meantime, it might be useful for you to try to think about how what we're doing here is related to the ideas you remember from your past. So anyway, what are we going to do? We're going to start off by thinking about the xy plane. Now, if we put an angle in standard position, like this, the question is, how are we going to define our functions cosine theta and sine of theta? Now, if you haven't even seen these functions before, these are just functions that are important to trigonometry, and we're just trying to build out what this thing could possibly mean. And so what we're going to do with this is we're going to imagine some point x comma y that lies on that line segment going out from the origin. Now, it doesn't matter which point we use as long as we don't use the origin, because whatever point we have, we can draw a circle of radius r that goes through it. And now this is starting to set up the ideas that we're going to need for the sine and cosine functions. First of all, the value of r. What is the radius of the circle? Well, by either looking at the distance formula, or in fact this equation for the circle itself, x squared plus y squared equals r squared, we can get the value of r. And once we have the value of r, we can get cosine theta and sine theta. Cosine theta is defined to be x over r, and sine theta is defined to be y over r. Now you'll notice that we had to pick a point that's not the origin, because if we pick the origin, we're going to be dividing by 0, and none of these are defined. You could also see that geometrically, if we picked our point at the origin, then there's no angle that's been defined from that point. And so this is the setup for the sine and cosine functions. We could do this in another way where we start with the point x, y, and then build the circle and then build the angle, and it will still give us the same final picture. So here's an example. The point 3, 4 creates an angle theta in standard position. Calculate cosine theta and sine theta. So what does this mean? If we draw our coordinate plane, the point 3, 4 is right here. If we connect this point to the origin, we create an angle in standard position, and that's called theta. Now our task is simply to calculate sine theta and cosine theta. Now, if we look at this, we can calculate this value r by looking at the right triangle that we create right here. This side has length 4, that side has length 3, and you might recall that this is a 3, 4, 5 right triangle if you've seen that before. Otherwise, we just plug it into the Pythagorean theorem. But we get, in any case, r is equal to 5. And everything from here is just a matter of plugging into the formula. Cosine theta is equal to x over r. This x value here is, well, that point was 0.34. So the x value is 3. This is 3 over 5. And sine theta, which is y over r, is equal to 4 over 5. And that's pretty much all there is to calculating the sine and cosine functions when it's set up in this way. I wanted to make two quick observations about this problem that we just completed right here. The first one is that we never actually calculated the angle theta. In this whole process, we calculate sine of theta and cosine theta, but we still don't actually know what that angle is. Now, if we stare at the picture, we can do some basic geometry. If we look at this, it's more up than horizontal, so that makes it look like the angle is bigger than 45 degrees. There are a few observations we can make like that, but we don't know the value of the angle. And that's something that you're going to have to get used to, this idea that this value of theta is just floating around out there. We don't know what it is other than from its representation here. Yes, there is some numerical value that if we were to go measure it, we could actually calculate. But for a lot of times, we just end up saying, well, whatever this angle theta is, it has these properties. Sine of this angle is this, and cosine of the angle is that. The second observation I wanted to make is that for this angle theta, we could have picked a different point to create a different triangle, but the sine and cosine theta values will still be the same. So if we had picked the point, let's say 6, 8, which sort of doubles this point, moves it up here, and we write out these fractions will reduce to the same thing. And so that's a very important fact about the sine and cosine functions, is that it depends only on the angle, and so not the specific triangle that you've created. We're going to think a little bit about the sine and cosine functions and the quadrants of the plane. Now here are the definitions again. Sine of theta is y over r, and cosine theta is x over r. And the thing to observe about this is that value of r is always positive. that means that when y is positive, the sine is positive. When y is negative, the sine is negative, and same with cosine and x. So let's think about the implications of that observation. So here's the xy plane. Now, if we are on this side of the y-axis, we will have x is greater than 0. We'll have x is greater than 0 down here as well. And if we're on this side of the y-axis, we have x is less than 0. Now, if we think about the y values, y positive is the upper half of the plane. So here, y is bigger than 0. Here, y is bigger than 0. And then when y is negative, you're on the lower half of the plane. Y is less than 0. Y is less than 0. But from the observation we made previously about the sine and cosine functions, this actually tells us everything we need to know about the sine and cosine functions. Cosine theta, if theta is in the first quadrant, is going to be positive, and sine theta is going to be positive in this first quadrant. In the second quadrant, if we look at this, we're going to see that cosine theta is negative, and we're going to see that sine theta is negative. Down here, we can say cosine theta is negative and sine of theta is negative. So this is quadrant 3. And then quadrant 4, cosine theta is positive and sine theta is negative. And so this is really interesting because what it means is that by looking at whether the sine and cosine functions are positive or negative, we actually know what quadrant the angle is going to be. So if we have them both negative, we're going to be in quadrant 3. If cosine is positive and sine is negative, cosine positive, sine is negative, we're in quadrant 4. And so this is a useful geometric relationship to keep in the back of your head as we look at sine and cosine functions of various angles.